All right, all my little babies, we are back, ready to rock and roll. Special segments quiz coming up. We got to know all these definitions. I told you guys this before, but you have to know all the different meanings. Even just not knowing the difference between circumcenter and incenter, that means you won't be able to get an A. There's just those two words are going to be worth over 10 points. You have to be able to know the difference, which means you have to put in some effort to know them. So the first one is the things that have to do with medians. Well, medians connect a vertex to a midpoint. They hit at a point called the centroid. The centroid is the center of gravity, and the centroid cuts the segment into a 1/3, 2/3 split. Boom, crushed it. The second one has with angle bisectors. Angle bisectors cut the vertex in half. They meet at a point called the incenter. The incenter is inside. It is equidistant from the sides. Incenter, inside, equidistant from the sides. Woo! Let's keep it going. We have one called perpendicular bisector. Perpendicular bisectors hits the midpoint at a right angle, meets at a point called the circumcenter, and the circumcenter is equidistant from all three vertices. Let's go! Altitudes. Altitudes start at a vertex and they're perpendicular to the opposite side. They hit at a point called the orthocenter. That's it. GG. Select all the properties that apply to mid-segments. There's three things. There's the definition, which is this guy right here. There's two properties that come as a result of the definition. We've talked about it in class, but they're always going to be parallel to the base and half the length of the base. Those are the things that apply to mid-segments. So let's do some actual problems. See how we handle it. We're given LP on this one. It says that LP is a mid-segment. That means that LP will be half of EZ. That's one of its big properties. So how many LPs does it take to make one EZ? It takes two of them. 2 times x squared minus 3.5x, two of those has to equal one of those. 2 LPs equals 1 EZ. So that would be 2x squared minus 7x. And this is a quadratic. So we want to make one side 0. Subtract the 2x squared over, I get x squared. Add the 7x over, get 7x. And then we have a plus 10 over here. So we eliminate everything from one side. And then we ask ourselves, all right, factoring. What factors of 10 add up to 7? That's the question. Factors of 10 that add up to 7. And they're going to be 5 and 2. And they're going to be both plus. How do we get plus 7 out of 5 and 2? Plus and plus. So x equals negative 5 and negative 2. So let's go back and plug it in. Well, plug in negative 2. 3 times negative 2 squared plus 10. That's going to be 4 times 3 is 12 plus 10 is 22. Is that an acceptable size? Absolutely. Okay, plug in negative 5. 3 times negative 5 squared plus 10. That's going to be 25 times 3. That's going to be 75 plus 10 is 85. So EZ could be 85 or 22. If I was really concerned on the quiz, I would also plug them in here. Those numbers should come out half. So when you plug it in there, it should be 11, and half of 85 would be 44.5. Okay, same idea, same picture, and these are all mid-segments again. So which segments are equal to PR? Okay, here's PR. So if those are mid-segments, that means P is the midpoint. That means these two parts are equal. So ZP would have to be equal. And AL would have to be the same size because, remember, mid-segments are half their base. So AL is half of ZR. Well, guess what? PR is half of ZR. So there we go. Yeah. For each blank, select whether in, on, or out. All right, guys. In center is inside, always. And also, as a side note, it's equidistant from the sides. In center, inside, equidistant from the sides. Love it. Then we have centroid. That is the center of gravity. Well, can you be the center of gravity and not be inside? No, it's going to be inside. So these two are always inside. I don't care what triangle we're talking about. In-center and centroid are inside. So how about the other two? These do move around. What are my phrases? For the other two, we have right on, right? Right on, dude. So where's the POC? If it's a right triangle, it is on, leaving obtuse to be out. All right, if someone's being obtuse, right, they're being frustrating or annoying, you're just going to get out of there. If you're being obtuse, I'm just going to get out of there. But if you're being acute, I might come visit. There we go. There we go. All right, for triangle ABC, ABC, it says BD is an altitude. So I want to start at B and be perpendicular to the opposite side and call that D. BD is an altitude. That's 90 degrees. And that says measure angle ADB, ADB, oh, that's this corner, is this. Well, that's if it's an altitude, that's got to be 90 degrees. So 2x plus 100 has to be 90. So 2x is negative 10, x equals negative 5. BD is a median this time. Okay, same picture. If it's a median, it hits the midpoint. So if AD is 5x and DC is 10x minus 100, and I know it's a median, then I know that 5x has to equal 10x minus 100. So 5x would equal 100, x would have to be 20. Let me go make sure that it asks for x over here. Yeah, x equals negative 5. This one says AC though. Well, if x is 20, this would be 100, and this would be 100, so AC would be 200. Medians have to hit the midpoint. If G is the centroid of triangle ABC. So guys, the centroid is the closest to the center of a triangle that you can get. It's when you draw the three medians. When you draw the three medians, they hit at a point called the centroid. There is no true center, but this spot right here is as close as it gets. Point G is my centroid. Okay. And before we even move on, right, it might be even easier to see, like if you're talking about like a rectangle or a square. Ah, that's not either one. A rectangle or a square. A rectangle or a square. Okay. And if you're at the center, well, there's no true center, but if you're at the thing that's closest to the center, what's going to be closer to you? The wall, like the side, or the corner? Right? If this is like a classroom, is the wall going to be closer or the corner going to be closer if you're at the centroid or the thing closest to the center here? Squares don't really have a centroid, but you know what I mean. The answer is the corner is going to be farther, so the wall is going to be closer. So what do we know about a centroid? We know it does a 1/3, 2/3 split, and the distance to the corner is your 2/3. It says M is the midpoint of BC, and AM is equal to 501. All right, so I'm actually going to erase these. I don't need those. But I know that G was like right here. AM is 501. Well, I know that 1/3 of 501 is going to equal, oh gosh, 300 plus 201. I don't even know. I'm going to type it in. 501 divided by 3 is 167. So I know that the distance from the centroid to the wall is 167. Well, the other piece is 2/3. So it's going to be double that. It's going to come in at 334, and that's the one they want. So it's a 1/3, 2/3 split. The distance to the vertex, the distance to the corner, is always going to be the farther distance. EZ is a perpendicular bisector for segment BC. Oh? So perpendicular bisector has to hit the midpoint at a right angle. So that's EZ is a perpendicular bisector for BC. I did it. Z is the midpoint of BC. Okay, so there's Z. Let's go see. What type of segment is AZ? All right, well, if I connect A to Z, what have I just drawn? Vertex to midpoint is going to be a median. If AB is equal to AC, oh my, oh my, oh my. Let's go back over here real quick. All right, everything's messed up. This is a scalene triangle. How do I know? Nothing's overlapping. Nothing's overlapping. Scalene triangle. All the points are different points. All the points are inside. I know it's acute. This is a scalene acute triangle. Now, what happens to this triangle when I make it isosceles? When I make it isosceles, whoop, boom. You see how those 4 points or those 4 lines became one? Boop. I know they're not perfect because it's kind of hard to get, but here, I'll try a little bit better. You think I do better, guys? Something like that. There we go. That's pretty close. Oh, I can do even better. I can do even better. I know I can. There we go. Let's go. All right. Now it looks real good. That's an isosceles triangle. I now know it's isosceles because those 4 lines became one line. That happens from the vertex angle. So if I'm talking about just perpendicular bisectors, so right now the black line is a perpendicular bisector. If I were to drag this corner so that it was on the black line, I bet you I can get real close again. What do you guys think? Yeah, something like this. I can't see under my finger, so I can't see where it is. Okay, I'm going to pretend it's right there. Now we know it's an isosceles triangle. How? Because the perpendicular bisector is going through... Oh, dear. Where did that even come from? There we go. It's not perfect, but it's awfully close. And the closer I make it, right, like you see it's a little bit off, the closer I make it, the more perfect it's going to get. See, that's pretty good. I bet you I zoom out. Look, it's, yeah, I mean, look at that. Okay, okay, I'm pretty good. But on an isosceles triangle, the perpendicular bisector goes through the vertex. And when that happens, it's all 4 things. Guys, if I were to measure let's give this a point here. If I were to measure the distance from A to D, oh my, I keep clicking the wrong things. A to D and B to D, they're the same thing. It's a median. It's also an angle bisector. If I were to measure this angle, CDB, it's awfully close. So it's a rounding issue. I mean, it would be 90. Again, I'm still not perfect. If I made it perfect, it would be exactly 90. But see, I zoom in, it's still not perfect. Okay, let's make it even closer. Can we do it? Okay. Did that make it 90? Come on. Did we get 90? I don't know. Oh, it's actually worse. I'm worse. Okay, whatevs. But you get the point here. I hope you get the point. So if I took this corner and dragged it to make it isosceles, would it also be an altitude? Yes, it would be an angle bisector. It'd be an altitude. It'd be a median. It'd be all the things. All right, and if BC is 10, how long is ZC? Oh, it had to be 5. There's our answers. Nice. CO is an angle bisector. So here's CO. It's an angle bisector. So it cuts the corner in half. Angle A is 50 degrees. Okay, angle A is 50 degrees. Got it. Angle B is 5x minus 10. And angle BCO is x. Well, that means this is also x. Well, how many degrees do the 3 corners of a triangle add up to, right? Isn't there one big blue triangle here? We know 3 of the corners. So we know that 50 plus 5x minus 10 plus x has to equal 180. I don't know why it does that sometimes. So we have 7x equals 140. So x equals 20. So this corner would be 40 degrees. Angle BCA would be 40 degrees, right? That'd be 20 plus 20 is 40. And this corner would have to be 100 minus 10 would be 90 degrees. So all I did was plug in the 20. So it's 90, 50, and 40. That means it's a right triangle. And because they're all three different, we know it's going to be scalene. So we have a right scalene triangle here, which is the next question. It'd be scalene and right. Wait, what? Don't know why. Okay, I'm dumb. It's be scalene and right. How do I know it's a right triangle? Well, one of the corners is 90. How do I know it's scalene? All the angles are different. So that means all the sides would be different. Therefore, it's scalene. All right, let's see what we got here. We got a triangle called JAM. We've seen this triangle before. And it says ME is a median. Okay, that means that ME hits the midpoint of AJ. So first job is to get the midpoint. The midpoint of AJ, we're going to do -5 plus 1 divided by 2. We're going to do 15 plus 11 divided by 2. That's how you get a middle. You add and divide by 2. We've talked about this a lot. And so when we do that, we get -2, 13. All right, but that's not the slope. They wanted the slope of ME. Well, we just got E, and they gave us M. So now we're going to get the slope from M to E. So what did we have to do? We knew it was a midpoint. We knew that a midpoint had to be in the middle, right? So we got the middle of A and J. That's how we knew where to put E. This is the middle of A and J. Medians hit a midpoint. They gave us point M, and we just found point E. Can we now get the slope of me? Yeah, so we're going to do the rise. How do you go from -1 to 13? Well, you would add 14. How do you go from 14 to -2? You would subtract 16. And that'd be -7 over 8. Next one. Triangle jam again. Lots of jam. J-A-M. What is the slope of altitude J-O? I'm going to change the letter so it's a little easier to see. I'm going to put J up here. So altitude J-O, it starts at J. Altitudes have to be perpendicular to the opposite side. Is that a midpoint? Do we find the midpoint? No. We actually, there's nothing, like that would be a really hard thing to find. We're not even going to attempt to do it. It would take a lot of work. But we just want the slope. So what do we know? We learned back in Algebra 1 that if you have a slope of A over B, that -B over A would make perpendicular lines. It's called the opposite reciprocal. So that's what we're going to do. We're going to get the slope of AM, right? If we can get the slope of AM, which we will right now, let's do it. 11 to -1, -12. 1 to 14 plus 13. So there's the slope from A to M. How do we then get the slope of J-O?
Stop and listen for a second.
You would do the opposite reciprocal.
There has been a change of plan.
Sorry about the announcements, guys. I'm going to keep talking. I don't think you can hear it too much. I know you can hear it a little bit. But we have triangle J-A-M again. And this time it's called a perpendicular bisector of the side MJ. So we're going to hit the side MJ at the midpoint. We're going to make a right angle at the midpoint. That's what perpendicular bisectors do. Or we hit the midpoint at a right angle. And we want the slope of that perpendicular bisector. Well, guys, the slope is going to be perpendicular to JM. We could get this. That's true. We could get the midpoint. But that's not helpful because that's just one coordinate. It doesn't have to go through A. So getting one coordinate's not super helpful. We need two coordinates. Well, we know J and we know M. And just like last time, we can get the opposite reciprocal of J and M. So let's do it. Let's do JM. 15 to -1. That's -16. -5 to 14, that's plus 19, so it's -16 over 19. That's JM, but we want the opposite reciprocal, positive 19 over 16. So perpendicular slopes are opposite reciprocals. So if you know two lines are perpendicular, get the slope of the line that you can, and then do the opposite reciprocal if you need the other one. Toothpicks form a triangle. So what would that look like? So what part of the triangle would be the toothpicks? Would it be the sides or would it be the corners? Well, it would be the sides. The toothpicks would be like the sides. What is the name of the point that's the same distance from all three toothpicks? What's the name of the point that's the distance from all three sides? And that's in center. The in center is inside, equidistant from the sides. The Texas DMV decides to build an office that is the same distance from three cities. At which point should you build a new office? From three cities. Well, looking at a map, would cities be points or lines? Cities would be places. Cities would be points. So what would be equidistant from 3 points? It's called the circumcenter. So circumcenter for points, incenter for sides. Answer each is sometimes, always, never. All right. If those 4 points are the same point, that is code for saying if it's equilateral. The only time that happens is on an equilateral triangle. Then it is isosceles, always. Equilateral triangles are a type of isosceles triangle. Equilateral triangles are always isosceles. If the centroid and incenter are the same, well, if 2 are the same, then they're all the same, and that's once again equilateral. I'm spelling this wrong. I don't know. You can spell check me later. If it's equilateral, is it isosceles? Always. A median cuts the vertex in half, then it's isosceles. If a median cuts the vertex in half, then it's isosceles. Yeah. It could be equilateral, but on an isosceles triangle, it happens one time. Going back to this situation, guys, if I make this isosceles like it is right now, yeah, the median cuts the corner in half. If I make it equilateral, it happens on every corner, and that's what I was talking about before. When I make it equilateral, now all the points are the same point, right? The 4 points line up. Everything lines up on every corner. All of the medians are the same as the altitudes, are the same as the angle bisectors. It happens everywhere now. All right. Altitudes are outside the triangle. Sometimes on an obtuse triangle, they'll be outside the triangle. We've definitely showed you that before. But like if I go over here, let's look at it real quick. If I make myself a triangle and I draw an altitude, so I didn't finish my triangle. If I go over here and I do a perpendicular line, boom, boom. Right now it's not outside, but if I were to move this, whoop, now look at that. That altitude is outside the triangle. That's an obtuse angle, and the altitude is outside the triangle. So we've talked about that. Yes, altitudes are outside the triangle. Sometimes they are. In an obtuse triangle, the centroid is equidistant from all 3 sides. When is the only time this happens? When it's equilateral. So basically they're saying an obtuse triangle is equilateral. Never. Never. Because on an equilateral triangle, all the angles are 60. Can you have 3 60s and be obtuse? No. So obtuse triangles are never equilateral. The incenter is equidistant from the sides. Incenter, inside, equidistant from the sides. That's its core property. Oh, this one's a challenge. CB's 15. CD. Oh, sorry. CD is an angle bisector. So start at C. Go to the opposite side. We know it cuts it in half. There's CD. It's an angle bisector. CD is 9, AC is 15. Find the perimeter of the triangle. This one's tough for a lot of people. You're going to have to make this connection, though. If it's an isosceles triangle, we just talked about that, 4 lines are 1. This is an angle bisector, but it's isosceles. That means it's also an altitude, it's also a median, it's also a perpendicular, it's all the things now. The 4 lines become 1 from the vertex angle. So if it's all 4 things, then this must be a right triangle. So what we have is a right triangle where one side's 9 and the hypotenuse is 15. So we know that a squared plus 9 squared has to equal 15 squared. So a squared has to equal 225 minus 81 would be 144. So a equals plus or minus 12. But can a side be negative 12? No, it's got to be 12. So we know the missing side is 12 and 12. So 30 plus 24, the perimeter is 54. Nice. So you had to realize you had everything. That's how we know it's a right angle. Tough question. How do you make 7 even? Take away the S. What did the janitor say when he jumped out of the closet? Supplies! Why was everyone worried about the calendar? Its days are numbered. Dun, dun, dun. Bye-bye.